Okay, so this time we will be discussing Newton's third law. Okay, so sometimes they call this the law of interaction. Sometimes, but I don't hear that most of the time. But third law, ang pinaka-shortcut ng third law is action-reaction. So halimbawa, pag merong isang object ay nag-exert siya ng force sa isang object, syempre tendency, yung object na yon is magre-react siya doon sa object na tumama sa kanya. Okay? Parang ano din, parang mga tao, halimbawa, ikaw, may tinusok ka, ganyan, syempre magre-react ka. Okay? And then, halimbawa, sa discussion naman natin, so let's say we have mass 1 and then mass 2. And then yung dalawa ay mag-uumpugan, let's say. So ito ay mag-exert siya ng force. Let's call that force 1, 2. So that's the force of 1 to object 2. And at the same time, kung ito tatamaan ng M2, yung M2 syempre mag-react. So it will react with the same force of 2 to 1. Okay, so by definition, yung force na yan na na-react ng 2 sa 1 will be of the same force na na-react ng 1 sa 2. Okay, so that's why it's called the reaction force. So kaya yung magnitude ng force 1, 2 is the same as the magnitude of the force of 2, 1. But they have opposite direction. Same magnitude but opposite direction. Yeah. Same magnitude but opposite direction. So yan yung ating Newton's third law. Okay, so anyway, before we proceed to, meron lang tayong mga i-introduce na concept and then mga forces. So, unahin na natin yung weight. Okay? So, unahin na natin ang weight. Weight is, ayan. So, weight depends on the surroundings. Unlike mass, mass is, ano kasi? Mass is constant anywhere in the universe, but weight depends on the environment. Okay? But weight, let's say on the surface of the earth, weight is always downward. Okay? So the magnitude of weight is equal to mg at yung kanyang direction is always downward. Ayan. So yung kakalimutan, weight is always downward. Ayan. So may question ba? Okay. So let's go to the next. Ayan. So weight. Ayan. Sabi dyan, the weight of an object on the Earth's surface is the gravitational force exerted on Earth by the Earth. So yeah. So as I mentioned. Okay, so your perception of weight is based on the contact forces between your body and the surroundings, which is true. But if your surroundings are accelerating or moving, your apparent weight may be more or less than your actual weight. Okay, so that's also true. Yeah. Okay. So it depends upon the surrounding kasi. Okay. Next. Yung normal force. Ayan. Okay, so this is our next one. So normal force. Okay, so what's a normal force? Okay, class. Kailan nag-exist ang normal force? So remember, normal force exists when the object is on a surface. Okay, if the object is not on the surface, so let's say it's floating or it's hung, so that means walang normal force na mag-exist sa kanya. So tatandaan yung concept na yon. Andyan, naka-mention naman dyan, the normal force is the force exerted by the surface on an object. So if the object is not on a surface, so that means there is no normal force acting on it. Okay, so example, okay, so let's have the normal force. So example, so let's say that the object is on a surface. Ayan. Okay, so let's say the object is on a surface, so that means there's normal force. O kung nakandiyan yung object natin, it's on a surface, there's also normal force. So let's say may ladder tayo, ganyan. Ayan. So there's also normal force. Okay, kasi nasa surface siya. Okay, ang question lang naman is, Ano ang direction ng normal force? Okay? Ano ang direction ng normal force? So, ang direction ng normal force ay, okay, ito, ang direction niya, okay, tatandaan ninyo, is always perpendicular to the surface. Okay, remember, mag-exist yung normal force pag yung object ay nasa surface. Doon lang siya mag-exist. Pangalawa, ang direction niya ay laging perpendicular to the surface. Perpendicular to the surface. If this is the object, okay, so this is a surface, so that means normal force is perpendicular to the surface. Bawa, ganito naman, ang normal force is always perpendicular to the surface. Kung naman ladder ito, since nandito may surface dito, so nandito yung perpendicular to the surface. N1. At the same time, since nakalin siya dito, so it's also perpendicular to the surface. Normal 2. On the other hand, yung weight natin is always downward. So kung ganito yung figure natin, weight is pa ganyan pa din. Kung pa surface, walang weight na pa left side or what. Ang weight natin is always downward. Ayan. Kung dito naman, ang weight natin is always downward. Ayan. But normal force is always perpendicular to the surface. It doesn't mean that the normal force is sometimes equal to the weight. It doesn't mean it's always equal to the weight. It could be less or it could be greater. Okay? It could be less or it could be higher than the weight. A normal force. Yeah, normal force. Okay? Okay, so the normal force may be equal to, greater than, or less than the weight. So, paano ba nagiging possible na equal to? Siguro dito, if the object is not moving, yung weight natin and normal force are equal. Yes, Darren? Kumusta na yung connection ninyo? Okay. Good morning. Ayan, let's say if that's not moving and it's on the surface, so that means weight is greater than, is equal to the normal force. But is it also possible that it's greater than or less than the weight? Okay, that's probably yes. Una, less than. Yung weight dito is greater than dito sa normal. Okay, kasi parang nagiging component lang ng weight yung normal. So hindi na sila magka-opposite kasi action-reaction ito. So yung reaction ng weight and normal, so dito equal sila. So dito since component na lang ng weight yung normal, so therefore parang mas maliit ang normal pag nakaganyan. Ganito din naman, kung normal dito, probably equal itong dalawa. Pero ang normal dito at saka yung weight dito, probably mas less yung normal dito compared dun sa weight. Una, hindi naman sila magka-same dimension. So hindi natin sila pwedeng equate. Okay? So siguro mas maliit yung normal dito compared dun sa weight natin. So that's possible that the normal is less than the weight. How about greater than? Ito medyo mahirap. Hindi naman siya laging nag-exist na normal is less than the weight. It's normal is greater than the weight. Okay, probably ganito. Ganito naman ang example natin dyan. So, halimbawa, meron tayong object. Yan, weight 1. So, siyempre, meron siyang normal. What if nag-apply tayo ng force? Ayan. So, kung nag-apply tayo ng force, gaya ng ginagawa ng dalawang bata sa figure, siyempre, kung weight lang ang pinag-uusapan, not the applied forces, so, siyempre, mas mataas yung normal kesa sa weight. Kasi class, kung mangyayari ay mas mataas yung weight, F1 and F2 sa normal, pag ganyan yung example, not like this or not like this, pag mas mataas yung dalawa compared sa normal, anong mangyayari sa object? Di ba babagsak? So, babagsak lahat. So, mag-accelerate na din siya. Kaya pag hindi siya gumagalaw, pero ganyan yan. So, that means, i-add natin yung F1, F2, tsaka weight 1, equal siya sa normal, which is then greater than dun sa weight. Pero, pag ito masyadong mataas compared sa normal, babagsak na yung object natin. So, magkakaroon na ng acceleration. Hindi na siya first law. Kasi magkakaroon na ng net force. Pupunta na siya ng second law. Ayan. And since hanggang nasa first law siya with the interaction of these forces, pero nasa first law pa rin siya or yung net force nila ay nagiging zero, so that means magiging nasa first law pa rin siya. Okay? Yun. Pag hindi kinaya ng normal ito, babagsak yung weight 1. Makukulog yung weight 1. Ayan. So, normal force, ang direction niya is always perpendicular to the surface. Always perpendicular to the surface. Okay, any question on normal force? Okay, let's proceed to the next one, which is related to normal, and that is the, yes, Angelo. Yes. Pero po, nawasak yung, pag po nawasak yung surface, doon po masasabi na net force is, yes, or there is net force not equal to zero. So, di ba yun yung definition natin sa first law? Okay lang naman na may force na nag-apply dun sa object, pero kung ang net force or yung mga forces na yon nagka-counter-counter sila, ay equal siya sa zero, so that means under first law pa rin. So kung under first law, net force is zero, walang acceleration. But if it so happen na yung net force ay hindi naging zero kasi hindi kinaya ng normal yung mga na-apply na object, so kung babagsak siya, magkakaroon ng acceleration. Okay. Oh yeah. So we can also say that the net force is greater than the normal kasi natalo nung tatlong forces, yung dalawang force plus yung weight, doon sa example natin at least dito. Okay, kung hindi kinaya ng normal yung tatlo, magkakaroon ng net force na hindi equal sa zero. Kasi masyadong malaki, mataas o malaki, powerful yung tatlo compared dun sa normal. Kaya di ba kung halimbawa, nasa isang, bawa may river and then you're trying to cross, pero bamboo stick lang naman ang nandito. Bamboo stick lang. Will you cross? Kasi yung i-apply na force sa iyo nung normal force or yung reaction ng bamboo sa iyo, baka hindi kaya kanyanin, mababagsak ka. Kung hindi magiging equal, hindi niya maka-counter ng normal yung weight mo. So that means kung mas mataas yung weight compared doon sa normal, magkakaroon ng acceleration. Yun nga, yung pagbagsak mo. Okay ba? Nag-gets mo ba, Angelo? Or you have other concerns? Okay. Okay, now let's proceed to the next force na pag-aaral natin today, yung friction. Okay, friction is related to normal. Okay, so that means ang formula kasi natin ng frictional force is equal to mu times n, wherein n is the normal force. Normal force. Okay? And then yung m is what we call the coefficient of friction. So meron tayong dalawang klase ng frictional forces. Okay? Yung una is tinatawag na static friction at yung pangalawa, yung F of S at saka yung F of K. So static friction, it means di siya gumagalaw. Di siya gumagalaw. So yung pangalawa, yung kinetic friction, it means it's moving. So yung frictional force na na-apply sa isang object na gumagalaw, we call that kinetic friction. At yung frictional force na na-apply sa isang object na hindi gumagalaw, so that is the static friction. Okay, given tayo ng formula, dyan naman, that the frictional force is equal to mu times n, where n that's the normal force, and then yung mu is the coefficient of friction. Kailan ba nag-exist ang friction? So ano ba yung definition ng friction? So the friction resisting, the force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. So if there are two objects which are rubbing each other, so parang ganon, so nagkakaroon ng friction. Kung walang interaction between the two, so that means wala. Kasi physical, di ba contact force ang friction? So that kailangan merong physical contact. But this doesn't just apply to solids. Pwede din naman siya sa fluids. Di ba mga fluids natin, yung mga gases and then liquids, kahit ikaw, halimbawa, nagbabike ka or naglalakad ka, di ba, may friction din naman ikaw at saka yung hangin. And even if pag nagsiswimming kayo, probably hindi mo din napapansin, there's also friction between you and the water. So imagine niyo kung walang friction, ikaw at saka yung tubig, baka mabagal kang lumangoy, di ba? So that is possible. Kaya meron din friction between you and the water. Tawag doon ay viscosity. Pero we'll not be dealing with that. When we go to fluid mechanics, we'll be studying that. But for now, sa Newton's law na subject natin, we will only be dealing with yung mga solids. Particularly mga surfaces, flat surfaces na interaction na ini-interact yung object natin at saka yung surface or ground surfaces natin. Ayan, so yun yung mga dalawang klase ng friction natin. So this one is the static friction, static, and then this one is the kinetic. Pero mostly ang gagamitin natin ay yung kinetic kasi nagmo-move yung objects natin. Static kasi is mostly nawawala na siya pag nag-start ng mag-move yung object. Pag nag-start ng mag-move yung object, yung static magiging na siyang kinetic. Okay, ang question niyan, class, ay ano ang direction ng friction? Okay, so let's saan? At wala. Okay. Wala. Okay, ano ang direction ng static friction? Or ano ang direction ng friction? Ano ang direction ng friction? Okay? Okay, class. Tatandaan ninyo, ang friction ay mag-i-exist siya pag merong yung object nasa surface. Okay? So that means there's normal. Kasi hindi mo mako-compute yung friction without the normal force. Ngayon, ano ang direction niya? Okay, direction. So, limbawa, andito yung object natin, ayan, at tinulak natin yung object natin in this direction. Okay? So, tinulak natin yan. So, that means, mag-move siya dito. So, mag-accelerate siya dito. So, yung velocity niya will be in this direction. Okay? So, class, tatandaan ninyo, ang direction ng friction is always opposite the motion. Okay? It's always opposite the motion. Okay, you always need to think where the object will be moving. Kung saan papunta yung object, opposite nun, yun ang direction ng friction. Natatandaan ninyo, okay? Friction. Ano ang direction ng friction? Is always opposite the motion. Kung saan papunta yung object, opposite noon, yun ang direction ng friction. So, limbawa, sa example natin ito, if the object is being pushed towards the right, so that means the object will move to the right. So therefore, what will be the direction of the frictional force? Okay, friction then will be opposite that motion. Since it will move to the right, friction will be going to the left. Okay, and it will only exist if there's normal force. And that means if it's the object is on the surface, so kung nandito yung normal, ayan. Okay, so yun yung ating frictional force. It depends on the normal force. Yung coefficient of friction naman depends on the surface. So depende sa roughness or smoothness ng surface yung ating frictional force din. So the more the rougher, tama ba yung term ko? The rougher the object or the surface, the rougher the surface, the greater the coefficient of friction. The smoother the surface, the lesser the coefficient of friction. So it depends on the surface. Okay? Mga class, ang question ko lang, anong napoproduce pag merong friction?
Heat po. Static.
Okay, tama ka. So, bakit ko tinanong yon? Later, after ng Newton's law, pagdating natin sa energy, we will be dealing with that again. So, alis alam nyo na yung sagot. Merong heat. Ayan. Okay, so, yan yung frictional force. Do you have any question? Okay, review lang natin ulit. Okay, normal, pareho silang on the surface, pero its direction is perpendicular to the surface. Ang frictional force is also on a surface, but the direction is always opposite the motion of the object. Ayan, opposite the motion. Okay, yan yung ating frictional force. Okay? Okay, so let's proceed to the last force na gagamitin natin. Yun yung tension. Tension. Minsan tinatawag siyang tensile force. Tensile force or the tension. Okay, kailan ba mag-e-exist ang tension? So nag-e-exist ang tension, okay, pag pinag-usapan natin to last time when we had the examples of forces. Okay, kailan ba mag-e-exist yung tension? Sabi dyan, tension is transmitted through a rope, string, or wire. So mag-e-exist lang yung tension kapag merong rope, wire, cable, and so on. Okay, mag-e-exist lang yung tension kapag may rope, wire, cable, string, ayan, basta may tali, mag-e-exist yung tension, the tensile force. So, halimbawa, meron akong object, ayan, so let's say this is mass 1, and then this is mass 2, tapos may tali between them, and then hilain sila kumwari ng force dito. So, may tension dito. And since may tali between M1 and M2, so therefore, may tension existing in that rope, or there's force existing in that rope connecting M1 and M2. Okay? Ayan. Okay. Ang question ngayon ay, ano ang direction ng tension? Okay. Ano ang direction ng tension? Okay, kung ang normal ay perpendicular sa surface, ang friction ay opposite the motion. Ang tension ay lagging away from the object. Okay, away from the object of away from the object you consider. Okay, tension is always away from the object. Okay, so let me have a poll. Meron yata nagtatanong. Kyle, yes, Kyle.
Sir?
Yeah.
Tanong ko lang po, like, may tawag po ba sa, example yung pagputol ng rope dahil sa sobrang tension?
Ay, sandali. Huwag mo na kayo may sumagot na, wala pa akong tanong. Sige, continue.
May tawag po ba doon, sir? Na-curious lang po kung ano po yun. Yung sa sobrang taas ng tension. naputol yung rope or wire.
Okay. Hindi niya kinakaya.
Opo, may
Yeah,
tawag
that's
po.
possible. Halimbawa masyadong mabigat yung nakatali. Kasi saan ba pinag-aaralan niya? Yung strength nung tali, yung pinag-uusapan na, yung capacity niya, parang ganon. May ano kasi na hindi naman lahat kayang buhatin ng or hilain ng rope or wire. So parang meron lang sa maximum na capacity yung tali na kaya niyang i-sustain na force para hindi mabali yung tali. I, I, I don't know what you call the term, pero parang um, I don't know. Um, Nasa strength of materials din kasi yon. At saka pagdating natin sa circular motion, that is very, very important. Kasi pag na-break yon, wala. May mangyayari dun sa object. So in that case, syempre, pag nabali, matitigil na yung application ng force. Meron lang kasi talaga silang strength. Nakadepende kasi sa rope and cables. In the term, maybe I'll check on that one. Normally, ano lang naman na?
Naisip ko po whiplash.
Whiplash. Oh, I never have read that term in our books. Sige, I will check on it. We'll see. Whiplash?
Joke lang po sa net pa pala yan. Whiplash na net.
Okay lang yan. Anyway, we'll try to find that exact term. Pero ang naisip ko is nasa strength of materials. Okay? At saan ba tayo? Ayan. So, can I change my poll because you answered without me asking yet? Do not answer. Wala pa naman akong question. Okay. So, here's the question. If I'll consider mass 1 dito sa ating figure at merong tali between M1 and M2, ano ang direction ng force? Ano ang direction ng tension? Tension sa M1. Ano ang direction ng tension or ng force ng rope doon sa M1? Left or right? Okay, class. Nakasulat ng direction dyan. Always away from the object. So kung ano yung kinoconsider nating object, dapat yung tension palayo sa kanya. Palayo sa kanya. I'm curious with the 6 people. Why you answered that? Ito yung object natin. Ito yung tali. Saan papunta yung tension? Tali. Mass. Object. Saan papunta yung tension? Bakit yan ang sinagot niyo? Mag-explain. Yung mga sumagot na mag-explain. Okay. So, ang poll natin. Papublish ko na even if some did not answer yet. Ayan. Ang sagot natin ay 23% answered left. 48% answered right. Okay. Siyempre, may class. Ito yung object natin. Ito yung tali. So, it's away from the object. So, therefore, dito niya hihilain. So, this is our direction of tension. So, the answer is to the right. Yan. Ito yung right. Right. Ito yung left. Right, left. Okay? Right, left. So, the answer is to the right. Okay. Next one. How about M2? What is the direction of the tension on M2? Left or right? Okay, so, okay, class. Hmm. What is the direction of the tension on M2? As I've mentioned, this is object per object. So it's always away from the object. Always away from the object. So this is M2 and there's tension here. Like that, tension here. You always think of this. It's away from the object. So it's away from M2. So that means, if it's away, paano yung palayo? Di ba lalayo siya sa M2? It's not moving towards M2. It's moving away from M2. And away is to the left. It's not to the right. If it's to the right, that means tinutulak ng tali yung M2. But remember, sasabihin ko parang ano, no? Ang tali ay ginawa na pangtulak. Never sang ginamit, ay sorry, maliktad. Ang tali ay ginagamit panghila. Never ginagamit ang tali na pangtulak. You always think of that. That's why it's always away from the object because you do not use ropes to push. You always use ropes to pull. That's why nasa third law tayo, action-reaction. Even though this is going to the right because we're only considering M1. And since we're considering M2, that doesn't mean that the tension here should be the same as the direction of the force, tensile force, to be exerted on M2. Kaya sa action-reaction, isa lang naman yung tension dun sa rope. Di ba nasa isang rope lang yan? So therefore, pareho lang sila. They have the same magnitude but opposite direction. Kaya yung tension dito sa rope, same magnitude lang yung dalawa, considering yung dalawang tali, yung dalawang object natin. But the magnitude is the same. But the opposite lang yung direction. Kasi action-reaction. Kaya ang kinoconsider lang lagi natin dito is object per object. Even though the tensile force on M1 is to the right, it doesn't mean that's the same direction of the tension or the tensile force exerted by the rope on M2. Kasi i-consider natin na yung direction niya is always away from that object. And therefore, the answer should be to the left. It's not to the right. Okay, class. This is very important. If you miss that one, so that means you will go nowhere. Yan ang first step natin. Yan ang first step natin sa pagsusolve ng mga ganitong klaseng problem. You need to identify all the forces. If you missed the direction of even a single force, that means mamamali ka na agad. Okay, yan lang ang una kong titignan sa solution ninyo. Pag nakita ko na may mali ka ng direction sa mga forces or may nakalimutan kang isang force, there's no way that you'll get the right answer. Okay? Remember that. So let's have a recap. Normal, it's on a surface, and the direction is perpendicular to that surface. Friction is also on a surface, and it is opposite the motion. Tension exists when we have ropes, cables, and so on, and the direction is always away from the object. Ayan. Ayun, idagdag na natin. Yung weight is due to gravity and the direction is always downward. Always downward, never sidewards. Always downward. Okay, so ito yung 4 forces and siyempre yung applied force pa natin. Applied force, siyempre depende naman sa given. Yan yung mga forces na i-consider natin at applyan din natin ng second law. Kasi net force ang pag-uusapan natin at ito ay mga forces at ito yung mga i-add nating forces. Okay? So, any question? Wala. Okay. So, let's proceed with some more things to consider. Ayan. So, let's have this figure. Ayan. Ayan. So, ang next part ng lesson natin is what we call the free body diagram. Ayan. Free body diagram. So, free body diagram, this one is the most important first step of our solution. Okay, so let's say this is M1, M2. Ayan. At merong, hey class. So normally ganyan lang yung ano natin, mga figure or given. Ayan. So let's say we are given an two objects which are connected through a rope and then being pulled by a force, applied force F to the right. If all the surfaces has a coefficient of friction, so may friction in all surfaces, ayan. So we need to identify or draw the free body diagram. Okay, free body diagram, parang yung object natin is gagawin lang natin siya ng dot. Yung object natin, let's say it's object per object. So let's say we have an object M1. So the drawing lang natin siya ng X and Y plane. At yung center will represent or the origin will represent yung ating mass 1. Ayan. So para laging part ito ng analysis natin. So pero bago natin gawin ito, kailangan i-identify muna natin lahat ng forces acting on each mass. Each mass ha, hindi yung buong system, yung isang object lang. So halimbawa dito, identify natin ano ba yung mga forces na nag-a-act dito sa M1. So na-mention natin sila lahat kanina. Ayan, may normal ba, may friction, may tension, may weight, or may applied force. Mass 1. So what are the forces acting on mass 1? Can you name one? Anyone can name one? Okay, Angelo, tension. Wait, isa-isa lang. Isa-isa. Okay, Angelo, tension. Ano ang direction? Okay lang na i-name ninyo because we need to draw it. That's why one by one, we need the direction. Okay, so that means to the right. Okay, so since may tali tayo dito, so that means meron tayong tension. Okay, next. Okay, Victor, friction. Where's the direction of the friction? What's the direction of the friction? Ay, sige. Sila sa sumagot. Okay, sige. Bakit? Okay, so kasi pag hinila sila ng F to the right, so that means mag-accelerate yung system to the right. So the motion is to the right. So therefore, tama ka, Victor. So friction should be opposite. Ayan. Friction 1. Next. What else? Okay, Ivan, wait is, what's the direction? Oh, it's not just, it's not enough you tell me the force. Okay, so it's downwards. So weight is downwards. Well, let's call that weight 1. Anything else? Okay, normal. What about normal? Okay, so perpendicular to the surface. So yeah, so upward. So that's normal 1. Meron pa? Meron pa ba? Meron pa ba? Wala na. Okay, so wala na. Sabi ni Ezekiel, wala na. Kasi wala nang na. Okay, next, how about mass 2? Tell me the force and the direction. Tension to the left. Okay, so because it's away from the away from the object, correct? Okay, so Benmar, sabi niya may friction. Okay, so that's F2. Ayan. To the left because it's opposite the motion. Correct, very good. Weight downwards. Okay, because that's always the direction of the weight. So weight 2. And ano pa? Meron pa ba? Okay, normal force, Benmar is, okay, normal force, perpendicular. So that's upward. So countering weight. So normal 2. Meron pa? Hmm. Think about it. Kung wala na, saan pupunta yung object natin? Nakakalimutan ko, napaka-importante. Napaka-importante ng force na yon. Okay, yung applied force. Paano kalimutan yung applied force? Hindi na siya gagalaw. Ayan. Yung applied force. Ayan. Tama ka, Benmar. Applied force. So ito, kailangan ng mga konting imagination kung anong mangyayari sa object if that force exists or not. Okay, so if we forgot the force, applied force, based dito sa drawing natin, pupunta siya sa kaliwa instead sa kanan. Okay, or the objects will not be moving. Ayan. Okay, after we have identified all the forces, now it's time to draw the free body diagram. Kaya yun yung first step sa paggawa ng ano natin, solve natin ang mga problems na ganito. And then, we'll apply na dun sa free body diagram. So, magdodraw lang tayo ng X and Y plane at yung origin will represent yung mass natin. And then, we will just draw all the forces acting on the object dito na para mas madali silang intindihin. So, ito yung FBD or free body diagram. So, ako, ang ginagawa ko is paganyan para madali ko silang maintindihan. So, yung weight 1 ay pababa. So, weight 1. Tension is pakanan, so tension. Normal 1 is pataas, so normal 1. And then friction is to the left, so that's frictional force. And then yung acceleration natin is to the right. That's very important. So that should be positive to the right. Di ba mas madali siyang intindihan kung doon kesa dito ka mag-base? So dito. So ito yung tinatawag na free body diagram. Now let's go to M2. Ayan. Ako, pag di ka siguro bilangin mo, 1, 2, 3, 4. 1, 2, 3, 4. Di 4 sila. So, okay. So, next. How about mass 2? So, that's sila tayo sa weight. So, I'll have weight 2. And then applied force to the right. And then normal force upward. Normal 2. Then tension to the left. And then I also have the frictional force to the left. Ayan. But acceleration is to the right. Ayan. Okay. Okay, may question ba sa first example ng pag-identify, pag-drawing natin ng free body diagram? Okay, wala. Now let's proceed to another one. Same, let's draw the free body diagram. Yung drawing ko ganyan. Ayan. Okay. Meron tayong coefficient of friction on all surfaces again. So, unahin na natin ang M1. So, what are the forces acting on M1? So, meron tayong dalawang object. M1 is on the surface and then hanging yung M2 pero connected sila sa isang rope passing through a frictionless pulley and then M1 is being pulled towards left. Okay, so let's start with M1. So, what are the forces acting on M1? Friction to the right. Kasi ang motion natin ay to the left. Okay, so kung pull natin dito, acceleration is yan, to the left. So therefore, friction is to the right. Okay, so tama, friction. What else? Sabi ni Benmar, tama yung si John. Sabi ni si Benmar, tension to the right. Okay, so tension dito kasi may tali because it's opposite away from M1. That's correct. Okay, Bettina, weight downward. Okay, so tama. So meron tayong weight 1. And then okay, tama din Ezekiel. Meron pa? Applied force to the left. Okay, so tama. Applied force to the left. Ayan. And normal upward. Okay, or perpendicular to the surface. Meron pa? 1, 2, 3, 4. Meron pa ba? Meron pa kayong na-imagine na force? Okay. Okay, wala na. Okay, next. M2. Kasi wala na talaga. Okay, M2. How about M2? Tension upward, correct? Tension upward. Ano pa? Okay, weight is downward. Okay, weight to. Meron pa? Is there normal? Okay, kasi wala naman siya sa surface. Okay? Tandaan niyo, walang normal kasi wala siya sa surface. At lalo nang walang friction kasi walang normal. Okay, so tama kayo? Tama. Okay, ang question lang is, ano ang direction ng acceleration ng M2? Okay, kasi imagine niyo ang M1 nagmo-move to the left, so therefore hihilain niya pataas yung M2. So tama ka, Benma. So ang acceleration natin ay positive kasi pataas. So ibang usapan pag pababa. Let's say baliktad dito, tinutulak niya yung M1 imbes na ipupull niya. So dito naman yung motion niya. No? So ang ano natin is pataas kasi. Okay? Now let's draw the FBD. Ayan, M1. So what are the forces on M1? So I'll have weight 1, downward, weight 1, tension, friction also to the right, normal is upward, and then the applied force to the left. Ayan. Okay, and then mass 2. Ayan. Nakalimutan ko, ang acceleration natin is to the left. Ayan. So acceleration is to the left. And then mass 2, you only have tension and then yung weight. Weight 2. Ayan. Acceleration is positive because it's upward. Okay. Ayan. So class, ano ba yung importance ng dalawang ito? Pag magsusolve na kasi tayo, gagamit lang tayo ng second law, which is the summation of force is equal to MA. Kaya lang, consider natin is by component para madali natin silang makita. Puro X lang and Y. And then summation of force along Y, so that's equal to MAY. So yan lang yung gagamitin natin lagi. Ayan. Kaya natin ginagawa ang mga FBD diagram para pag nag-apply tayo ng second law, ayun, it's per component. Okay. Now, let's proceed to my favorite example. So this one is my favorite. I also like this one, giving to my students to solve. Ayan. Okay, pag in-apply ko ang force sa taas, so may friction on all surfaces. Okay, all surface. Pag nag-apply ako ng force sa M1, ba't pareho M2? M1, pag nag-apply ako ng force sa M1, hihilain ng force na yon ang M1 to the left. Since connected ang dalawa, M1 and M2, ng isang string na dadaan sa isang frictionless pulley, may hila yung M2 dyan. At the same time, nakapatong yung M1 sa M2. Ayun. So dito natin maano yung imagination ninyo. How will things or the forces will exist sa M1 and M2. So unahin na natin ng M1. So what are the forces acting on M1? Give me the force and the direction, okay? tension to the right. Okay, so if you're talking about the cable, the rope here, so okay, so tension to the right. Normal force downward. Benmar, are you sure? Okay, so we'll skip Benmar first. So we'll have weight downward. So we'll have weight 1 downward. Okay. And then acceleration to the left, ang sabi ni Cal. So M1 ang pinag-usapan natin. Okay, so tama. Acceleration to the left. Wait muna. Huwag mo lang sasagot. Isa-isa. Ang sabi ni Charles Gabriel, friction to the right. Okay, so pag pinag-uusapan natin yung friction ng M1 and M2, so motion ng M1 ang pinag-uusapan, so tama, friction to the right. Let's call that F1. So may hindi ba i-consider surface yung M2? Yes, you're correct, Benmar. I-consider na surface yung M2, but the direction of normal is. What do you think? But it's not downward. It should be countering. It's action-reaction. So it should counter or opposite the weight. Tama ba? Yes, it's upward. So magre-react yung M2 sa M1 at ang reaction ng M2 sa M1 is upward. So normal 1. Kung hindi nag-react yung M2 sa M1, baka lulusot yung M1 sa M2. Kaya magkakaroon ng normal force yung M2 sa M1. Okay. Anything else? We forgot the applied force. Remember nagsabi ng applied force? Ayan. So weight, tension, friction, normal. Okay. Meron pa? Wala na? Ang nagsabi ng siyempre magko-comment. Ang nagsabi ng ay magko-comment. Ang nagsabi ng meron pa, siyempre magko-comment. Pero siyempre, kung walang magsasabing meron pa at puro lahat magwala na, we'll proceed. Meron pa bang force tayong nakalimutan sa M1? Or wala na? Na-identify na natin lahat? Yun yung question. Na-identify na ba natin lahat? Meron pa bang force na hindi tayo nakikita or na-identify na acting sa M1? Meron sabing meron pa. You tell me. Ezekiel, ano pa? Yeah, we have that applied force. Okay. Wala na pala. Si Angelo, how about you? Meron pa ba? Nagano meron pa. Okay, kung feel mo meron pa, ano pa? Baka meron kami hindi na identify. Yun la. Okay. So, hindi ka lang sure, no? Okay, pero actually wala na. Ayan. So next, let's proceed to mass 2. Okay. So mass 2. Mass 2 na tayo. Okay, so give me the force. Give me the force at the direction. Tension right. Okay, Salmar, you're correct. Tension to the right. That's right. Acceleration to the right. Okay, so it will move to the right. So acceleration ng M2 is positive. That's to the right. Normal force perpendicular. So that's on the ground. Tama ba, Bettina? On the ground. Okay, so let's call that normal 2. What else? Friction to the left. So dito ba? Okay, let's call that F2. Kasi motion is to the right, so friction is to the left. Okay. Anything else? Weight downward. Weight 2 yan, Kyle. Kyle, weight 2 ba yan? Okay, so weight 2. Weight 2, downward. Sabi ni Benmark, friction. Friction to the right. Which one? Benmar. This one, tension. Victor, this one. It says it's to the right kasi it's away from M2. We're only considering M2. Remember, the direction of tension is always away from the object. So it's to the right, not to the left. Friction between M1 and M2. Okay, wait. Sasabi ni Charles Gabriel, masasama po ba siya sa diagram ng M2? Ito ang question. May interaction ba yung dalawa? If we will consider M2. To the right to. To the right. Yes, may interaction kasi pag gumalaw M1, gagalaw din. Okay? So you're correct. Okay, ang question niyan is, ano ang direction ng friction between M1 and M2 considering M2? Okay, Charles, Kyle, you think of this. Ano ang direction ng friction? Lagi. Generally speaking. M2 to the right. You're correct. So therefore, what's the direction of friction? Okay, it's to the left. So that means considering M2, friction 1 here is equal to the same as the friction before, pero ang direction niya is to the left. It's opposite the motion. So opposite ng motion ng M2, not M1, M2 which is to the right. So therefore, friction between M1 and M2 considering M2 should be to the left. Na gets ba? Dapat meron din tayong friction dito. F1. Friction between M1 and M2. So dalawa ang friction natin sa M2. friction between M2 and the surface, and then friction between M1 and M2. Kasi ganitong mangyayari. If yung direction of friction between M1 and M2, considering M2 is to the right, that means ihilain ng M1 o isasama ng M2 yung M1. Isasama ng M2 yung M1 papuntang kanan. So that's why it should be opposite. Okay. Okay, next. M1 po yung naisip ko kanina. Okay. Okay. So M2, Charles. So okay na tayo sa F1. Kasi ang kino-consider natin dito yung M2, not M1. Ang effect lang ng M1 sa M2. But not the motion of M1. It's the motion of M2. Okay. So, meron pa ba or wala na? Ang nagsabing meron pa, mag-i-explain. Bakit may tension sa M2 to the right? Di ba may nakatikit, may tali sila? So that means may effect yung tali dito sa M2. Okay, so therefore, ano ang direction ng tension sa M2? Diba it's always away from the object. So that's why it's to the right. Yes, yes. Yes, Gal, tama. Okay, so wala na ba? Sabi ni Sam, wala na. Okay, class. You are missing one more thing. Meron pang isang nawawala. Isa pa. Walang sumasagot na meron pa. Actually, meron pang isa na hindi natin. No, not the applied force. Because applied force is on M1. Ano pa ang force na na-apply sa M2? Meron pang isang nawawala. Isa na lang. Okay, it's not the combination, Cal, but the weight of M1. Okay, so that means merong effect yung weight ng M1. So that means we also have weight 1. Gets you ba? So may effect yung weight ng mass 1 sa mass 2. Kyle, it will like confuse us more if we will add another variable. For me, but if it works for you, that's okay. But for me, I do not introduce another weight if there's no other mass. Nakuha mo ba? But if it works for you, it's okay. But I don't do it that way. But if it works for you, I don't mind. Okay, now let's draw the FBD diagram of all of this. Ayan. So let's have a mass 1. Okay, so mass 1 will start with force, applied force. So applied force ay nandito. And then we have the weight 1, yung mga naka-red, weight 1. Tension to the right. And then friction to the right as well, friction 1. And then yung normal upward, normal 1. Ayan. Okay. Let's proceed to M2. Yan, M2. Okay, sa M2 natin, so we'll start with friction 1. So friction 1 is to the left. Weight 2 is downward. Weight 1 is also downward. Friction tension is to the right. And then normal 2 is upward. And then friction 2 is to the left. And acceleration dito ay pakanan, that's positive. Yung acceleration dito is pakaliwa, which is negative. Ayan. So, meron ba akong nakalimutan? So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ayan. Okay? Ayan. At saka tayo summation of forces along x is MAX. Then summation of forces along y is equal to MAY. Okay? Yes, Ivan. Naligaw, naligaw ka. But dalawa yung friction sa M2. Okay, 'di ba meron tayong friction on all surfaces? Sinabi ko kasi lahat ng surface may friction. So, there's a friction between M1 and the ground and the surface. Friction between M2 and the surface. And then there's also friction between M2 and M1. Yes, Ivan. Okay, so while you're reading, Kyle, after na drawing ng diagram, so kailangan po isulat yung formula ng summation of forces. This is the first step. This is the second step. Ang third step natin is sa second law na tayo. Pag magsusolve na tayo. Yes, Charles. Yeah. Di pa tayo magsusolve ngayon, but when we go there, gagawin na natin yan. Magkahiwalay. Okay, gagawin natin yung summation of forces per object, per mass. No. This is just the first step, first two steps of your solution, of your analysis. So, buti po doon nakalagay yung weight to doon sa axis. Dito, kahit saan, ang importante, alam mo lang kung pababa siya or pataas. Dito, pag kasi pinagpatong ko, nakakalito lang. Ang importante, alam mo kung pataas ba siya or pababa. Pakanan ba siya or pakaliwa. Yun yung pinaka-importante. Okay, ito ay part lang ng solution natin. So, kung pag-aaralan nyo na yung mga example natin sa module, so, ibig sabihin nun, ayan, kung pag-aaralan nyo na yon, ito yung unang part ng solution natin. Dito tayo magbe-base doon sa computation natin using second law. Okay, puro lang tayo naman sa second law, yung F is equal to MA. Ayan, pero in terms of components, X and Y. Okay? Kaya class, napaka-importante na imagine niyo pag na-miss niyo yung F1 dito, yan, it's impossible for you to get the correct answer. That's why you need your imagination kung ano yung mga forces na maapektuhan or na-apply sa object per object. Okay? Kaya din, class, tignan ninyo, may effect yung friction dito sa normal 2, di ba? Ang normal 2, yun yung gagamitin natin sa formula ng F2. At kung iintindihin natin, yung normal 2, may kinalaman yung weight 1 at saka weight 2. Pag-add natin sila. Kung nakalimutan niyo yung weight 1 para makuha yung normal 2, mamamali ka sa frictional force. Okay? So let's have another one. I think this is the last one. Ayun. Isa ito sa mga pinaka-importante din. Dahil may madami tayong ganyan na object. Minsan, nakaganyan. Bawa ganito. Ayan. Mga ganyan yung mga examples natin. Nakadikit, nakaslant, nakadikit, nakaslant. Ayan. Pero dito, isa lang naman ang gagawin natin. Okay, paano natin i-deal ito? So, ganun pa rin naman, identify din natin kung ano yung mga forces acting on the object. Yan, nakaslant siya. May angle na. Okay, so una is yung ating weight. Tandaan ninyo, weight is always downward. Ayan. Okay, and then normal is perpendicular to the surface. That's the normal. And then we also have the applied force. Okay, kung may friction tayo on all surfaces, ano ang direction ng friction? Okay, kung ang applied force is pataas ng inclined, so yung friction is opposite that. So that will be okay, down the incline. Tama ba? Down the incline. Down the incline. Dito ko na lang susulat, frictional force. Kasi ang acceleration natin ay pataas. Ayan. Okay? So, ang gagawin natin ay meron tayong X and Y plane. Ayan, yung X and Y plane natin. So, let's draw the free body diagram. So, yung free body diagram natin, ganyan. Ayan. Kaya lang, class, dito ay mag-rotate tayo ng axis. Ito yung importante. Mag-rotate tayo ng axis. Anong ibig sabihin ng rotation ng axis? Yung X and Y plane natin is i-rotate natin siya such that yung x-axis natin, ito yung common na, ito yung laging ginagawa. Yung x-axis natin ay ipaparallel natin siya sa surface. So parang ito, ipaparallel natin siya sa surface. So ang dating ay parang ito ang ating magiging bagong x and y-axis. So ito yung x, tapos ito yung magiging y. Ayan. So para mas madali yung analysis, itatapat natin yung x and y axis kung saan madami yung tatama na doon yung direction nila. Okay, so ang mangyayari ay if kaya niyo siyang i-flip yung papel ninyo, ganyan, ayan. So ito yung ating y axis at ito yung ating x axis. Okay? Ayan. So dyan natin pagbabasihan yung ating forces. Wait, Angelo is typing something. So, mangyayari ay, ito yung x, ito yung y. So, unahin na natin ang applied force. So, applied force is to the x-axis. F. Ayan. Okay, and then, normal is upward. And then, frictional force is to the left. Okay, and weight is on the third quadrant. Ayan. Yeah. Yes, yeah. Actually, tinitilt, gaganyanin natin yung solution nyo. Ako is, niro-rotate kasi natin yung axis. Hindi, para makita nyo lang yung x and y plane na bago. So, x and y. Kaya ako siya tinitilt. Para madali siyang intindihan. So, sa bagong x and y axis natin, yung friction nasa along x. So yung applied force and also the frictional force. Kyle, yun yung susunod natin. Yan. So that will be the next one, Kyle. So saan natin nilalagay yung theta? Dito sa ating x and y plane. Kung nandun yung theta, saan natin nilalagay yung theta dito? Okay? So, sige, diderive ko. Diderive ko na lang. Okay, class, kung i-diretso natin ito, magiging perpendicular ito. So that means itong ay magiging right triangle. So therefore, let's call this alpha. Ayan. So if we will do that, alpha is 90 minus theta. 90 minus theta. Okay, kung i-diretso natin ito, since itong dalawa ay parallel, so therefore, ito ay also alpha. And that means kung alpha yon, ito ay alpha. Ayan. Okay, kung alpha yon, so that means ito ay magiging theta. So nandito yung theta. Right. So nandun yung theta. So, ang kino-consider kasi natin, di ba, summation of forces along X and Y. So, that means, this will be WY, sorry. At nandito yung WX. Ngayon, paano nyo kukunin ang magnitude ng WY at saka WX? So, yung WX is equal siya sa W sine theta or W cosine alpha. So, it's up to you on which one you want to use. Okay? And yung WY natin is W cosine theta or W is equal to sine alpha. Okay, di ba, if you will go back to this figure, ayan, so ito kasi ay magpo-form, is straight natin yung weight ay, at saka yung surface natin ay magpo-form sila ng right triangle. Kung right triangle yan, yung angle dito between yung weight at saka yung surface, tawagin kong alpha. Eh since right triangle yan, complementary yung alpha and yung theta. Kaya yung alpha will be equal to 90 minus theta. Eh since ito ay vertical, ito at saka to parallel sila, so that means yung angle dito at saka angle dito ay equal. So kung alpha ito, alpha din ito. At yung alpha yun, so that means ito yung alpha. Alpha ito yung alpha. Eh kung ito, diretso, ito ay perpendicular, so that means perpendicular ito, nagpo-form din to ng 90 degrees. So complementary rin sila. Eh since ang alpha is this one, so therefore, nandito yung theta. Kaya, nandito yung theta. Ayun, kasi alpha yon theta to. So, syempre, theta ito. Kasi alpha is 90 minus theta. Complementary kasi sila. Pero pag nasanay kayo, usually, kung ano yung angle doon, lagi siyang nakadikit sa y-axis. Lagi siyang nasa y-axis. Pag nasanay-sanay na kayo na alpha lagi nandito. Yung theta is always nandito. Yung angle. Kaya lang, huwag yung gagamitin na yung x is cosine. Kasi ang x nandito, di ba? So nandito yung x, opposite siya ng theta, so opposite siya ng theta, kaya nagiging w is sine theta is equal to x, wx. Pero yung mga civil, ang convention nila is laging kinukuha yung alpha. Hindi nila kino-consider yung given. Ang kino-consider nila is alpha. Para yung cosine ay laging x at yung sine ay laging y. Pero pagdating kasi, if you will consider theta, dahil ang wy nakadikit ang theta sa wy, so cosine siya. At yung wx malayo sa, or opposite niya yung theta, nagiging sine yung theta para sa x. At nagiging cosine yung theta para sa y. Okay? Any question? Ayan. So, kung wala